Security-RSA algorithm. It is a asymmetric key algorithm. This algorithm is named after the three scientists who introduced this algorithm, Rivers, Shamir and Alderman. And we have 6 steps in this algorithm. First step is to choose two prime numbers P and Q. So we will consider 7 as P and Q is equal to 17. In the second step, we have to calculate n is equal to P into Q. So n is equal to 7 into 17. So totally we will 119. And the third step is select public key. We have to choose the encryption key as key, and it should not be a factor of P minus 1 and Q minus 1. So in P minus 1 and Q minus 1 we will get totally 96 as an answer, and we should not consider the LCM value of 96, that is 2 or 3. So instead we will choose E as 5. Then the fourth step is selecting private key D. So for selecting the private key we will have the formula D into E mod P minus 1 and Q minus 1, which should be is equal to 1. So here we are substituting the E value as 5 and mod into 7 minus 1 and 17 minus 1, which is our P and Q. So then we consider 77 as D, and we have to multiply 77 into 5 mod 96. So totally we get 385 mod 96 is equal to 1. In this 77 we have to calculate by mode, and one clue is it will be the less value than the 96, less value than the P minus 1 and Q minus 1 value. In the fifth step, the formula is for calculating the ciphertext is equal to plain text power encryption key mod n. So plain text is 10, so 10 power 5 mod 119, totally we get 40 as answer. And calculating the plain text is equal to ciphertext power d mod n. So we will take the answer of ciphertext 40 and decryption key d is equal to 77 and mod 119, so totally we get 10 as answer, which is our plain text. The next algorithm we will see about diffie-Hellman key exchange algorithm. It was introduced in the year 1976. It is a key exchange algorithm and not an encryption or decryption algorithm. Totally it has 5 steps. In the fifth step we should consider K1 and K2 value, which must be equal, which means the attack will not happen. In the first step we should consider prime number Q is equal to 7, and in the second step we should consider the alpha value, which should be a primitive root of Q, and it should be the less than value of Q. And in the third step we should assume the XA value, which is a private key of user A, and it is also the value of it should be also the value less than the Q value. And we will consider XA is equal to 3, and we should substitute the XA value in the formula of Y. YA is equal to alpha per XA mod Q. In this formula we should substitute that XA value and Q value and the primitive root, that is alpha value. So YA is equal to 5 per 3 mod 7 and 125 mod 7, totally we get 6 as the answer for YA. And the fourth step is we should assume the value of XB, which is also the value less than the Q value, and we should substitute the value in the formula YB is equal to alpha per XB mod Q, and XB value we are considering it as 4, and we will substitute in the formula YB is equal to 5 value, which is the alpha value, 5 per 4 is XB value, and mod 7 will be our Q value. So 625 mod 7, totally we get 2 as answer. And after getting all the answer, we collect all this. XA is equal to 3, XB is equal to 4, YA is equal to 6, YB is equal to 2, alpha is equal to 5, and Q is equal to 7. And we'll substitute all these values in the K1 and K2 values. So fifth step is calculating the secret key of K1 and K2. For calculating K1, we'll have the formula of YB per XA mod Q, and we'll substitute the YB value 2 per 3 mod 7. So totally we get 8 mod 7 and 1 is the answer. And we'll substitute the K2 value in this formula YA per XB mod Q, and YA value is 6 per 4 mod 7 and 1296 mod 7, which is equal to 1. So here K1 is equal to 1, K2 is equal to 1, so that the keys are shared